8051 programming in C. So, why do we go for programming in C? So, when you program in C, the compilers produce the hex files that can be downloaded to the ROM of the microcontroller. Okay, so in this particular case, the size of the hex file is the issue. And since the microcontrollers have limited on-chip ROM and the code space is limited to 64 kilobytes. And the advantage of C programming is that C programming is less time consuming, but the size of the hex file is larger when compared to the assembly level programming file. So the main reasons why you go for writing programs in C as opposed to the assembly language program is it is easier and less time consuming. It is easier to modify and update and can use the code available in the function libraries, and it is portable to other microcontroller without or no modification, with little or no modification. So these are the main aspects of C which helps us in coding in C rather than in assembly level programming. So in some kinds of project, it will be beneficial to code in C rather than in the assembly language programming style. So next is the data types as specified in your syllabus, the variable declaration. So these are the different types of data types available in C to create the small hex files. So it is signed character, unsigned integer, signed integer, single bit, bit and SFR. SFR we know, special function register. The character data type is the most natural choice. Mostly we go for the character data type, unsigned, signed character data type. So we know already that 8051 is a 8-bit microcontroller, and unsigned character means it is a 8-bit data type. So 8051, since it's a 8-bit microcontroller, it is very uh, easy to use unsigned character type, since that's also 8-bit data type. And we know that all the registers in the 8051 are 8 bits in length, which we use for data handling. So 8-bit means 0 to FF. So that is 0 to 255. And the most widely used data type for 8051 is counter value and the ASCII characters. So if we go for the C compilers, then they use the signed character as default if we do not put unsigned character. So if we don't specify it as unsigned, then by default it will be taken as signed only. So if you just put it as character, then it will take it as signed character. So this particular program we dealt with in talking about the key programming. Uh, so this was 8051 program to 8051 C program. Okay, that means it should be a C program, not a assembly level program. Not ALP, it should be a C program. To send the values 00 to FF to port P1. Okay, so as we have already discussed, uh, if we are writing a 8051C program, hash include, here what we write is register 51.h, not stdio.h. So this particular program is specific to the 8051. So that is specified by writing register 51.h. Then we write void main void, and here the character type or the data type is unsigned character is it. So and what we are going to do is transfer the data 0 to 255, that is 0 0 to ff continuously to p1. Okay, so for that what you are doing is you are putting a for loop. So for z equal to 1 to 255. So is it equal to, how is the syntax? For z equal to 0 semicolon z less than or equal to 255 z plus plus, that is z is incremented every time once. Okay, 0 then 1 2 3 like that up to ff. So each of those values are transmitted to P1, and if you check P1, if you are using the Keel software, you can check the peripherals, and in that the port P1. So if you see the port P1, you can see that it will change values from 0 to 255. Now the second program is write an 8051C program to send the hex values of ASCII characters of 0, 1, 2, 3, 4, 5, A, B, C, D to port P1. Okay. So in the earlier case, it was just integer values. Here we are sending the ASCII characters. So here again include register 51.h and void main void is the same. The data type used is again unsigned character, and the name given to this is to the string is mynum, and these are the values that should be transmitted 0 1 2 3 4 5 A B C D, and character Z is also defined as unsigned character, and for z equal to 0 to 10. Why 10? Because 0 1 2 3 4 5 6 7 8 9. So 0 to, in total there are 10 ASCII characters. So this should be displayed in port P1. So how do you do that? You are giving this particular string to mynum. So and z value is changed. So what is P1? P1 is mynum of z. So it will be mynum of 0. Then this should be displayed. That is then mynum of 1, mynum of 2, mynum likewise till d. So all those values, the corresponding hex values of these ASCII characters, this is specified as ASCII how? Because it's in quotes. Okay. So those values will be displayed in P1. So what we are talking about here is port programming. How do you program the port? How do you send data to, to the port? Next typical example is to toggle all the bits of P1 continuously. Okay, so P1 is forever toggled, that is continuously toggled infinitely. So this double slash is for the comment. So these two comments are, sorry, these two statements are same for all. For in parenthesis semicolon semicolon. So that means that forever toggle P for uh, this just means that infinitely, forever, this loop should be infinitely processed. So what is inside the loop? P1 equal to 0, 55H, and P1 is then AAH. Okay, so 0x 55 means 55 and 0x AA means AAH. So here there's a small mistake. If you type in Keel software, this P1 should be in capital letters. Okay, these two should be in capital letters. So what will be the output of P1? First of all, it will be 55, then it will be AA, then 55, then AA. Why do you say that it is toggling? If you write 55, it is 0, 1, 0, 1, 0, 1, 0, 1. AA is 1, 0, 1, 0, 1, 0, 1, 0. So 55 and AA are complements of each other. That's why we are saying that they are toggling. And forever, how? By putting it in a loop for in parenthesis, semicolon, semicolon. Okay. So that is unsigned character, some examples. Next is signed character. So signed character is an 8-bit data. Again, in the case of unsigned also, it is 8-bit only. Both are 8-bit data types. And in signed character, the MSB or the D7 is represents the sign plus or minus. And it gives values from minus 128 to plus 127. In the other case, we got it from 0 to 255. Why? Because all the 8 bits are taken as value. In this case, the D7 is taken as the sign bit. So we will use the unsigned character in all cases unless we are using a signed number, so that we can go for a larger range of values. Okay, so that is mandatory. We will go for unsigned character unless and otherwise we are going for signed numbers. If you are going for signed numbers plus or minus, if that is relevant, if the sign is relevant, then we will go for the signed character. So this example is write an 8051C program to send the value -4 to +4 to port P1. Okay, so here there's a spelling mistake. Include and void, it's the same. So we previously told that if character, if the data type is written as character, then it will be by default taken as signed character. Okay, if you want unsigned character, then you have to specify unsigned character. Okay, if you are just writing as character, char, then that means that it is signed. Okay, so it is character minus equal to, so what are we going to do? +4 to -4. So plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 plus 4 minus 4. We are sending. We have not written 0. Just the signed numbers. Okay, since 0 does not have a sign, it's not written, because D7 will then be taken as the sign bit. So we are taking only positive and negative numbers in the range +4 to -4. And character Z is taken as unsigned only this is taken as the signed. So you can see that here you've taken curly brackets. Okay, you've specified the values inside the curly brackets because these are values, and in the earlier case when you took the ASCII characters, you put it in quotes. For z equal to 0 to how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 8 z is incremented, and that is value, that is minimum of z is transmitted. That is z equal to 0 means plus 1 will be displayed. Z equal to 1 means minus 1 should be displayed. Likewise, all the values should be displayed in P1. So all these are port programming. So we told about the first two data types. One is the unsigned character. In unsigned characters, you can specify values from 0 to 255. Signed character, you can specify the values from the D7 since it's used for to specify the sign. You can give values from minus 128 to plus 127. Next is unsigned integer. So that is a 16-bit data type. So the unsigned character and signed character were 8-bit data types. In unsigned integer, it is a 16-bit data type. So it takes values from 0 to 65535. Okay. 16-bit means 2 raised to 16. So 00000 to FFFFH. So this is the range of values. So in a particular program, you have to see what is the range of values you are dealing with, whether it is positive or negative. So what is the kind of data type you are using, and depending on the data type, depending on the kind of data you are dealing with, and specify the data type. You can declare the that particular variable as such and such data type. So 16-bit variables such as memory addresses. If you want to specify memory addresses, then you go for unsigned integer. Or set counter values of more than 256. If you want to set counter values more than 256, then you can go for unsigned integer. So registers and memory access are 8-bit. So don't use int variables in the case of if you are dealing with 8-bit data. If you're just dealing with 8-bit data, don't go for unsigned int or integer. Why? Because it will take up more space. So your hex file will be bigger. So a microcontroller anyway has limited space. So write the program efficiently. So that is unsigned int, and signed integer, that is also a 16-bit data type. In this case, D15 is taken as the signed bit. And this is the range of values minus 32768 to 32767. So write a program to toggle D0 of the port P1, that is P10, 50,000 times. Okay. So here S bit. So S bit, what it does is it allows the access to the single bits of the SFR registers. Okay. So S bit, my bit equal to P10. Okay. So this will give access to the single bits S bit is single bits of the registers. So P10 you need to toggle 50,000 times. So integer Z is unsigned integer since we are dealing with 50,000. Okay, we are dealing with 50,000. So that's a counter value which is greater than 255. So you have to go for a 16 bit. So you're writing it as unsigned integer. You don't need signed integer because you're not dealing with any sign, positive or negative. It's just a counter. So for Z equal to 0 to 50,000, increment, and my bit. What is my bit? P10. So my bit is first 0, then my bit is equal to 1. So this will go on. How many times? 50,000 times. Okay. So just remember which is the data type you will be using for a particular program depending on the kind of data you are using. Then till now we have only dealt with the for loops. So here since we are dealing with a particular bit in the port P1, that is why we went for S bit. So this particular data type bit and SFR allows access to single bits of the bit addressable memory space from 20 to 2FH. So these are the data types we are dealing with in C programming. Unsigned character, we discussed that 8-bit, and the data range. Signed character 8-bit, you can even write it just as character, CHAR, 8-bit, and the data range. Unsigned integer 16-bit, signed integer or just integer means signed. If you don't write signed also, it will mean signed only. That's also 16-bit. So unsigned integer, in the earlier case we had to deal with 50,000, so it falls in this particular range. It does not fall in these two ranges. That's why we went for unsigned integer. S bit, that will deal with a single bit. In the earlier case P10, we just needed a single bit. That is why we went for S bit. So SFR, bit addressable only. And if you write bit, again 1 bit, that is for RAM. And if you write as SFR, it is 8 bits, and from the range is from RAM addresses 80 to FFH. So next is how to create a time delay in 8051 C programming. Okay, so we know how to write a delay program in where ALP, assembly language programming. We know how to create a delay. If a particular delay of so many seconds or milliseconds is specified, we know the clock frequency. Using that, you can design a particular delay. So how do you do the same using C programming? So there are two methods. One is using the 8051 timer, or by using a simple for loop. So again we have discussed how to write the delay in the case of ALP. So in that, machine cycles and the clock periods, that plays a major role. The crystal frequency plays a major role. So here in this particular case, C programming, the compiler choice, which is the type of compiler you are using, that plays a major role. So the C compiler converts the C statements. C statements means the program statements and functions to assembly language instructions. So if you see in key programming, when you write the program in C, the corresponding ALP is also generated. The different compilers will produce different codes. So let's talk about a program where to toggle the bits of P1 continuously forever with some delay. Okay, so earlier we discussed about toggling the bits of P1 forever. But maybe in that particular case, you can't actually differentiate between the toggling because there is no delay in between. We had discussed about 55 and AA. So it will be continuously going. So you may not be able to differentiate between this AA and 55. So you want to introduce a delay in between AA, then that will remain in AA position for some time for a particular delay. Then 55, that will remain there for some time. Then again AA, likewise. So this is the same. So it is so 4 forever, repeat forever. Okay, P1, again P1 should be in caps. P1 equal to 55 for x equal to 0 to x less than 40,000. So so we are dealing with a large count value, that is why we went for unsigned integer. So that is the delay size we are okay, here the delay size is unknown. Okay, so 0 to 40,000. So 55, you're putting a for loop for x equal to 0 to 40,000. Then P1 equal to AA, again a delay. So this is one method for introducing a delay using a for loop. Okay. So if this value is smaller, then you can go for unsigned character. Okay. You went for unsigned integer only because you are dealing with a larger counter value. Count as a larger value, larger than 255. That's why we went for unsigned integer. So here the delay is specified. In the earlier case, delay is not specified. Here the delay is specified as 250 millisecond. So ms delay, and that is unsigned integer. While one means repeat forever. P1 equal to 55, ms delay 250. So this means that 250 millisecond. ms delay means millisecond delay 250. P1 equal to AA, ms delay 250. So between these two toggling, you are introducing 250 millisecond delay. So this should be declared outside the loop, outside the main. Void ms delay unsigned integer. Then we are defining the ms delay. So void ms delay unsigned integer I time. So unsigned integer I comma j for I equal to 0, I less than I time I plus plus. For j equal to 0, j less than 1275 j plus plus. Now suppose LEDs are connected to bits P1 and P2. Write a program that shows the count from 0 to FF on the LEDs. So this is define LED P2. So P1 equal to 0, 0 means clear P1. LED equal to 0. That is P2 is defined as LED. So LED equal to 0 means P2 equal to 0. Forever P1 plus plus, that is P1 is incremented. LED plus plus, that is P2 is incremented. So 0 to FF. So first clear P1 and P2 and then increment it, and this will continue forever from 0 to FF. Write a 8051C program to get a byte of data from P1, wait for half a second and then send to P2. Again ms delay, unsigned integer. So what we need is get a byte of data from P1, wait for half a second, then send to P2. Get the data in P1, wait, then send to P2. Okay. So my byte is defined as unsigned character. P1 is FF. So P1 is the data. Forever my byte equal to P1. So my byte gets the value FF. MS delay. So that is the wait period. 500 millisecond. So that's the wait period. Then P2 equal to my byte. So P1, the data which P1 gets, that is specified here. Then my byte gets the value from P1, and this my byte is given to P2 after a delay of 500 milliseconds. Get a byte of data from P0. If it is less than 100, then send to P1. Otherwise, send to P2. Get the data from P0. So P0 gets the data. Here it is FF. If it is less than 100, so check what is the value of this. If the value is less than 100, then give to P1. If it is greater than 100, then send to P2. So, oh sorry, FF means it is making it the input port. Okay. Here also P1 equal to FF. Okay. In the case of EdSIM, by default it was made an input port only. It's all the ports are made input port. So in this particular case, like we studied in the theory, if you want to make a particular port as the input port, then you have to make all the bits equal to 1. So that's why we are writing FF. So here also P0 is made the input port forever my byte equal to P0. So whatever value you are giving inputting at P0, that is given to my byte, and check what is the value of my byte. If it's less than 100, then P1 gets the value, else P2 gets the value. So you have to enter the actual data through the input port in the hardware. So in order to make a particular port as the input port, write FF to that particular. That is what was done. So sorry about that. Toggle only bit P24 continuously without disturbing the rest of bits of P2. So we are dealing with a single bit. So we'll naturally write S bit, my bit equal to P24. So it is always written as Px raised to y, likewise. Okay, so that is the format of writing P24. Forever, my byte equal to 1, my bit equal to 1, my bit equal to 0. So this will toggle forever. What will toggle? My bit. My bit, what is my bit? It is P24. So how do you specify a particular bit? By using the S bit format. Monitor P15, if it is high, then send 55 to P0, otherwise send AA to P2. So we have dealt with these programs in assembly language programming. We are dealing with the same in C programming. So again we are dealing with a single bit. So write S bit, my bit equal to P15. Then you are going to make this my bit, that is P15, as an input port. So that is made equal to 1. Since it's a single bit, just write as 1. If you are going to make a complete port as the input port, then you'll be writing FF to that port because it's a 8-bit port. Then forever, if my bit equal to 1, so understand that you are putting double equal to sign, my bit equal to 1, then P0 equal to 55. So if my bit, that is if P15 is equal to 1 is high, then send 55 to P0. So P0 will get 55, else P2 gets AA. So that is, those are some of the programs in port programming. So we talked about 6 type of data types: unsigned signed character, unsigned integer, signed integer, S bit, bit, SFR. Okay, so you can check the other